We're constantly hearing about what large language models can do, right? But how do we scientifically measure the language they actually produce? Well, today we're diving into the paper Corpus Linguistics and Artificial Intelligence by Tony Berber Sardinha. It presents a really powerful framework for getting under the hood of AI-generated text to see how it truly stacks up against human language. Let's get into it. We're going to break this down into 5 key parts. First, we'll unpack the paper's central argument and its context. Then, we'll get grounded in the core concepts of register and multidimensional analysis. From there, we'll explore 2 new terms the paper coins to describe the unique nature of AI language. We'll then see this whole framework in action with a specific case study, and finally, we'll pull apart the findings and what they really mean. All right, so let's start with that central argument. What is the fundamental problem in the world of AI and linguistics that this paper is setting out to address? The core idea, stated right there in the abstract, is that if we want to truly understand AI language, we need a very specific tool from Corpus Linguistics, a register-based multidimensional analysis, or MD analysis. The paper argues this isn't just one option among many, it's an especially suitable route for bringing scientific rigor to a field that's moving at an incredible pace. We'll be unpacking what that analysis actually is in just a moment. To make its case, the paper lays out a very clear 4-step plan. First, it just wants to demonstrate that you can, in fact, apply these linguistic tools to AI texts. Next, it uses MD analysis to identify the key patterns of variation, first within AI language. Then, it does the exact same thing for human language. And that final, crucial step is to put those 2 analyses side by side for a direct, evidence-based comparison. To really grasp the paper's argument, we need to understand the tools it's using. So in this section, we're going to define the essential concepts: corpus linguistics, this idea of register, and the multidimensional analysis that ties them together. Okay, let's start with corpus linguistics itself. Drawing from the work of Berber and his colleagues, the paper defines it by 4 main characteristics. It's empirical, meaning it looks at how language is actually used in the real world. It uses a corpus, that's a huge, organized collection of texts. It's heavily computational, relying on software to find patterns you'd never see by hand. And finally, it combines quantitative data, like word frequencies, with qualitative, human interpretation. This is the bedrock of the entire approach. Now for arguably the most important concept here, register. A register isn't about what you're talking about, but how and why you're talking about it. It's the way our language systematically changes depending on the situation. Think about the difference between an email to a professor versus a text message to a friend. The vocabulary, the sentence structure, it all shifts to fit the communicative purpose, the audience, and the medium. A register is the term for these consistent, situation-driven linguistic patterns. And this slide illustrates that concept perfectly. Just look at the typical linguistic features of 2 very different registers. Conversation is interactive and personal, so you see things like personal pronouns, contractions, and active verbs. Academic prose, on the other hand, is all about informational focus. That reads to dense, impersonal constructions like nominalizations, turning verbs into nouns, and a lot more passive voice. The key insight here is that these features don't just show up randomly. They co-occur because they work together to serve the functional needs of that specific situation. So, how do you actually study these clusters of features? Well, the research design is absolutely critical. The paper highlights Berber's 3 design types. You see, just looking at one feature at a time, like the frequency of a single word, that's type A. Or trying to look at the entire corpus at once, type C, that just won't work for this. The sweet spot is the type B design, where the individual text is your unit of analysis. It allows you to see how different linguistic features cluster together within each text, which is essential for the kind of multidimensional analysis this paper relies on. Okay, so now that we have the foundational concepts, let's see how the paper applies them to AI. And this is where we get to the really novel theoretical contributions for understanding the unique nature and the inherent limitations of AI-generated language. The whole problem is framed by this one question. LLMs learn from these massive data sets, but how do they actually perceive and reproduce the kind of functional, situational variety that we just defined as register? The paper proposes 2 new concepts to explain the challenges they face. The foundational issue is what the paper terms the blob problem. LLMs are trained on text scraped from the internet, but that data isn't typically organized by register. You have academic articles, blog posts, personal emails, forum comments, all of it gets mixed together into a single undifferentiated whole. Without explicit labels marking the communicative context, the model's ability to learn these crucial distinctions is fundamentally kneecapped from the start. This blob problem leads directly to what the paper calls register deficit. It's this systemic lack of register-specific knowledge in LLMs, because their training data isn't tagged with context. This is a formal letter, or this is a casual conversation. The models can't properly learn the crucial link between a situation and a specific style of language. They learn what's common overall, but not what's appropriate for a specific context. And the observable result of this deficit is what the author calls register metamorphosis. This is what happens when an AI produces text that, on the surface, might look like one thing, say a conversation, but its underlying linguistic features and communicative function actually belong to a totally different register, like an FAQ document. The result is this kind of distorted, hybridized Franken register that imitates the form without fulfilling the function. So these are really interesting theoretical ideas, right? But do they actually hold up when you look at real-world data? Well, the paper puts them to the test. We're going to focus on the first of two case studies, which looks at text created for English as a foreign language, or EFL textbooks. This study, which comes from Shimizumi and Berber Sardinha, compares model texts used in EFL writing instruction. Now, the crucial point here is that this is not a comparison of natural versus artificial language. Both human-written textbook examples and the AI-generated texts are, by their very nature, artificial. They're both constructed for a pedagogical purpose. The real question is whether they represent comparable forms of artifice. To run this comparison, a human-authored corpus was put together, called the English Language Teaching Texts, or ELTT corpus, and this chart shows you its composition. It contains 500 texts in total, and you can see it's nicely balanced, with 250 texts from the B2 or upper intermediate level and 250 from the C1 or advanced level. This ensures a really solid basis for comparison across different stages of language learning. And this table gives us a look at the different registers inside that human corpus. As you can see, there's a wide range of text types that you'd expect to find in language teaching. Things like essays, summaries, formal letters, informal letters, and so on. This diversity is really essential for testing the AI's ability to replicate these specific, function-driven text varieties. Now, the method for generating the AI texts was actually very clever, designed to avoid simple imitation. It was a two-part system. First, the AI would read a human text and create a writing prompt based on it. Then, after a delay of several hours and a command to forget the original text, it was fed the prompt that it had created itself and told to write a new model text. This makes sure the AI is performing a genuine writing task based on instructions, not just rephrasing something it just saw. All right, so the stage is set. We have the human texts, we have the AI texts generated through this rigorous process. Now, for the most important part, what did the comparison actually reveal? Let's get into the findings and their implications. The results of the MD analysis were stark. The AI-generated texts were consistently found to be more informational, more abstract, and more impersonal in their linguistic makeup. In sharp contrast, the human-authored texts, even though they were also artificial, consistently showed linguistic features associated with interpersonal awareness, expressing a stance and engaging the reader. The two types of artificial texts were not functionally equivalent at all. The paper synthesizes these results to make a much broader point. In the textbook case, the AI clearly demonstrated a register deficit, and a second study on AI-generated pop lyrics found evidence of register metamorphosis. When it was asked to write rap lyrics, which are often rooted in specific personal conflict, the AI instead produced generic, motivational anthems, what the paper calls moralized empowerment discourses. Across very different genres, the AI exhibits the same core limitations: register deficit and register metamorphosis. So, what's the ultimate takeaway from Berber Sardinha's paper? It's that we now have a validated, powerful methodology for really looking under the hood of AI language. Register-based multidimensional analysis lets us move beyond simply asking, is it fluent, to revealing the deep functional differences in how AI and humans actually use language. It provides a scientific roadmap for understanding what AI language truly is, not just what it looks like on the surface.